Hello my dear students, welcome back to Learn Physics. In today's video, we are continuing with our ray optics portion. And today's topic is dispersion. So last class we learned about the refraction through prism and the minimum deviation, those formulas and all we did, and the graph also. So today we are going to do with dispersion. Dispersion through a glass prism. What is meant by dispersion? What is meant by dispersion? Splitting of white light into its component colors, that is called a dispersion. So this is a glass prism. When white light is incidenting on it, it will divide it into its component colors. Here we can see violet will be the most deviated ray and the red will be the least deviated ray. Okay, so dispersion of white light, whether it is which and all factors it depending, or not dispersion, deviation. Deviation depends on which and all factors. Deviation depends on wavelength of light. As wavelength of light increases, deviation will become less. As wavelength increases, deviation will become less. Red is the most, is having longest wavelength, and violet is having less wavelength compared to the red. Okay, so it is having, red will be having, deviation of red is very much less than deviation by violet, since lambda of R is very much greater than lambda of B. That is, lambda and delta are inversely proportional to each other. Now, what is the relation connecting this refractive index? See, n is equal to, according to Cauchy's formula, n is equal to a plus b by lambda square plus c by lambda cube plus etc. A, b, c and etc. are constants. So n is inversely proportional to wavelength square. That means as wavelength increases, refractive index also decreasing. That means as wavelength increases, the refractive index decreases. So here, this one you can remember. Right? As wavelength increases, deviation decreases, and the refractive index of the medium, also the refractive index also will be reducing. So n is, lambda is, as wavelength increases, refractive index of the medium decreases. Clear? So for violet rays and the red rays. So how we can calculate that? Clear? Next we are going to study about the angular dispersion. What is meant by angular dispersion? Angular dispersion is, dispersion means splitting of white light into its component colors. We know minimum deviation also. Deviation. What is meant by deviation? From incident ray, how much of angle it is deviated. Emergent ray, how much it is deviated. Here, angular dispersion is the difference in deviation between the extreme colors. Which are the extreme colors? Violet and red. Delta V minus delta R. This is the difference in deviation between the extreme colors. So that is called a angular dispersion, or theta. I am representing it as delta theta or d theta I am representing. So angular dispersion is the difference in deviation. How much of deviation happened for this? See, while this is delta V. Okay, and this is delta R. So delta V minus delta R, that is an angle. So angular dispersion, that is delta V minus delta R. Okay, so now how can we represent it in terms of refractive index? Last class we learned about the refractive deviation is equal to n minus 1 into A, right? So here we can write it as nV minus 1 into A minus nR minus 1 into A. So we can write it as NV minus NR into A. So angular dispersion depends on the angle of the prism and the refractive index. Refractive index of for the medium for each color of light. NV minus NR into A is the angular dispersion. In terms of refractive index, we are representing delta theta. So it is the difference in deviation between the extreme colors. Next, we are going to learn about dispersive power. What is meant by dispersive power? Dispersive power is represented as omega, that is equal to angular dispersion divided by mean deviation. So what is angular dispersion? Just now we learned it is delta V minus delta R, right? Divided by delta. So in terms of refractive index, if I am writing down NV minus NR into A divided by N minus 1 into A. So it is a dimensionless constant, is a dimensionless value. Delta dispersive power is NV minus NR divided by N minus 1. It is not having any unit and it is depending on the material of the medium. It is not depending on the angle of the prism, just material it is depending. Okay, and here the angular dispersion is depending on the material of the medium as well as the angle of the prism. But dispersive power depends only on the material of the medium. Clear? Then next is this angular dispersion, whether it has any dependence with the wavelength. Yes, angular this derivation is there, that is not required for you. Delta theta is inversely proportional to lambda cube. Okay, so this one deviation, angular dispersion is inversely proportional to the cube of wavelength of light. So which is, we know the formula, these dispersion and all. A natural phenomena which is obtaining in this through this dispersion is rainbow. Rainbow, it's of two types of rainbows are there. It's primary rainbow and secondary rainbow. What is meant by primary rainbow? In the case of primary rainbow, I'll explain over here. See, when a ray of light is incidenting here, it will undergo refraction and dispersion. So red and violet. So it will, after that, it will be undergoing total internal reflection, and here also it will undergo total internal reflection. Light ray will be observed in such a manner. Okay, so we will be getting the red over here, violet over here. When we are observing through here, we can see that violet is the bottom surface violet we can see, and the top surface we can see red. Okay, so violet is at the bottom and red at the top. Like that we will be observing. So in this one you can see two refractions are happening. One's at this side and one's at this side. And here when it is coming, it is total internal reflection. So here two refractions and one total internal reflection will give you primary rainbow. Primary rainbow means we can see violet color at the bottom surface and red at the top surface. But here in the case of secondary rainbow, if it is secondary rainbow when we are considering, see the ray of light will be incidenting in such a manner and it will undergo deviation and it will undergo here once more it will happen. Here once more it will happen and you can see that the ray of light is here. This is the incident ray. It is converting to red to violet, and this is the violet and this is the violet. Here it is red. So violet is coming at the top surface and red will be coming at the bottom surface for the secondary rainbow. If we are discussing, while we are discussing about the secondary rainbow, there the phenomena is happening are same only: refraction, total internal reflection and dispersion. These are the phenomena which are happening over here. But along with that, number of total internal reflection is more in the case of secondary rainbow. And as you know, to observe the second rainbow, the sun should be behind us. And we will be under during rainy season, that and all you know. It's during rainy season, after the rain, since water droplets are there in the atmosphere, that water droplets will be acting as a prism, glass prism. It will it will be acting as a prism, and we will be getting this rainbow. So whenever this light ray is incidenting and the total internal reflection is happening inside that, then only this rainbow can be observed. So it can be a primary rainbow or can be a secondary rainbow. In the case of primary rainbow, we will be observing violet at the bottom surface, and the just or reverse is the case for secondary rainbow. Okay, in the case of secondary rainbow, there are 2 refraction and 2 total internal reflection will happen, and dispersion also. Clear, children? So now we are going to do some numerical related to this topic, and last class I told you about one homework question. So we will discuss that one first, and then afterwards we will do some numerical relating to this. Okay. I'll read out the last class question. A ray of light is incident on face AB of an equilateral glass prism, shows a minimum deviation of 30 degree. Calculate the speed of light. That was the first question. So equilateral prism, therefore angle equals 60 degree, and it is minimum deviation is given as delta minimum is given as 30 degree, and we need to find out the speed of light, V. Okay, so n is equal to sin a plus d by 2 divided by sin a by 2. N you can find out, n is equal to c by v. That was a direct question. We'll do that. Okay, in this you should find out the angle of incidence at face AB, so that find the angle of incidence at the side AB, so that the emergent ray grazes along the surface AC. So through the other surface, the ray should be, total internal reflection should happen at the other side. So here angle is present. So we should find out the angle of incidence when total internal reflection happens. It's not given like that. Through AC it is grazing towards the surface of separation. That was the question. So here we need to find out. For that, n is equal to sin a plus d divided by 2, the whole divided by sin a by 2. So here sin of 90 by 2 45 divided by sin 30. Sin 45 is 1 by root 2. And sin 30 is 1 by 2. So here you will get it as root 2. Okay, that is n. So n is equal to c by v. So 3 into 10 to the power 8 divided by v equals root 2, 3 by root 2. So while you are calculating, you will get it as 2.12 into 10 to the power 8 meter per second. This one you will 1.41 you can substitute and find out the answer. Now, see, at AB, when it is incidenting at AB, instead of going, instead of emerging through AC, it is going through this point. So, how this angle of refraction will be happening? What will be the angle of incidence? This is the question. Here I will draw the diagram once more. See here, A, B, C. Here light is incidenting like this, and at that time it will incidenting over here, after refraction then going like this. Okay, so this is 90 degree. Here critical angle it will be, right? So what will happen over here? This will be angle of refraction for that side, and this is the angle of incidence. So here we can, since we have n value, we can find out this one. Right, n is equal to sin c divided by sin 90. Sin 90 is 1. So refractive index of the glass will be equal to 1 by sin c. That how we are taking refractive index of second medium with respect to first medium is sin I by sin r. So it is 1 by sin c, and you will get it as, so sin c equals 1 by refractive index of glass. Refractive index of glass we found it as root 2, right? So 1 by root 2. Therefore what will be C? C will be sin C equals 1 by root 2. C equals 45 degree we are getting. So here we are getting it as 45 degree. Okay, if this is 45, how much will be this one? This is 45 degree. Here it is 60 degree. Then what will be this much? 180 minus, yes, 180 minus 105. Here we are getting it as 75 degree. So here we are getting it as 75. So what will be this one? 90. So R will be equal to 90 minus 75, that is 15 degree. So at the surface AB, N is equal to refractive index sin I by sin R. Therefore, sin I equals N into sin R. N already we got it as root 2, sin of R is 15 degree. So when you are calculating, you will get this value. Clear? So this is easy one. Actually calculation is not that much, but many things are included over here. Refractive index of second medium with respect to first medium. In this kind of questions, all of you please keep that in mind. Refractive index of second medium with respect to first medium. That is N2 by N1 is equal to sin I by sin R. So which is the first medium, which is the second medium? That one always should keep in mind. Clear? Now next question is, a combination of two prisms, one of flint and other of crown glass, produces a dispersion without deviation. The angle of flint glass prism is 15 degree. Calculate the angle of crown glass prism and angular separation of red and violet rays on emergence from the spectroscope. So here values are given, angle of the, so we have the flint glass and crown glass prism. Okay, angle of the flint glass prism is given as 15 degree. We need to find out the angle of the crown glass prism. A dash I am giving. This one we need to find out. For that, this refractive index of the crown glass is given as N dash is given like 1.52 and refractive index of the flint glass is given as 1.65. Then omega for the crown glass is given as 0.02 and flint glass is given as 0.03. What is this omega? Omega is the dispersive power. So dispersive power is given like this. So angular dispersion divided by mean deviation, that is this dispersive power. So this is given. We need to find out A dash. How can we find out? Here it is given no deviation is happening when it is passing through these two, dispersion without deviation. That means delta deviation happened in flint glass, and when we are considering both the dispersions, it will be equal to 0. So here delta equals n minus 1 into A. So n minus 1 into A plus n dash minus 1 into A dash, that is equal to 0. N minus 1, 1.65 minus 1 is 0.65 into 15 plus n dash minus 1, 0.52 into A dash equals 0. Therefore A dash equals 0.65 into 15 divided by 0.52. So it is negative. You can calculate this. You will get the value of A dash. Okay, clear children? This is how we will be finding out the angle of the second prism. Clear? So I hope it is clear for you. And this one here, this formulas, and this one 1 mark question, like 1 mark, 2 mark questions and all. Many questions can be asked from this side. So all of you keep all these points in detail. Okay, so if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.